Hello everyone. Welcome on in. This is going to be a video on genetic programming. So we're going to do a quick and dirty video, pretty much, more about the programming and less about Unity. And I'm going to show you basically what genetic programming is. If you know what genetic programming is, this is probably not going to be all that anything for you, because it's just going to be an explanation, really. And I'm going to make it as simple as possible and have as few variables as possible, that kind of thing. So, we're going to do it in Unity because it makes it easier to visualize. And we're going to start out with making a terrain. And then to make a terrain, you go to 3D Objects, and you make a terrain. And then we're going to save our scene so that we don't lose anything, and we have the scene saved. So we're going to call it scene 1. Make it nice and easy. And then to make this all nice and organized, we're going to call this scenes. Normally there'd be more than one, so that makes sense. It doesn't make sense for one scene though. And then we're going to go models, and we're going to stick terrain under models, and then we're going to start. So to begin with, we're going to have to create a spawner, which is going to be an empty game object, and we're going to rename it spawner object. There we go. And then we'll move them around later. For right now, they can stay where they are. Where they are particularly doesn't really matter, so we'll keep them where they are for now, and we'll move them around when we're all set and ready. So for the spawner object, we're going to need a script. So we're going to need another folder. We're going to call it scripts. And then we're going to go into that folder, and we're going to create a new C# script right there. You can use whatever programming language you're doing. It doesn't matter. You can do genetic programming in all of them, but for this tutorial we're using C#. So we're going to call this the spawner script, just like that. And then we're going to double click on it. Now, I'm not using MonoDevelop, I'm using Visual Studio because I had it and I like it. But if you're using MonoDevelop, it should be pretty much the same. I'm not going to be doing anything fancy or super difficult in Visual Studio. So, here we are in the spawner script. But we need to come back here because we need something to spawn. So what we're going to do is we're going to create a 3D object, and it could be anything. It could be any of these, or you could make your own, or it doesn't matter. It could be whatever it is you want to spawn. So for right now, we're going to spawn, yeah, let's go with Bouncy Balls, yeah? And we're going to call this a Bouncy Ball. There we are. And as you can see, it's got the collider, the meshes, all that nice stuff. So for right now, I don't like this material on the empty terrain. You can customize it as you want if you're doing it on your own, but for right now, to make it simple, I'm not going to be putting any custom assets in here. It's all going to be just color picker and what's in Unity already. So because this material doesn't really show off against the terrain, we're going to have to make another material. So we're going to make another folder, and we're going to call it materials. And then we're going to go in here, and we're going to make a new material. And then we're going to call this Bouncy Ball. Ball mat. There we go. And basically I'm just changing the color. So we're going to come over here, And we're going to go, I don't know, something like that, so we can see it. We come back to our bouncy ball, and we just drag and drop right there. All of a sudden, our bouncy ball is a different color, which is good. Now we can see it. And now we need to take this and make it a prefab. And to do that, you basically take it, drag it, and drop it down here. And now you have a bouncy ball prefab. And there you go. That's how you make a prefab. So this is what we're going to be spawning. So we're going to get rid of this here. We're going to delete it. And we're going to come back into our spawner. And we're going to add our C# script. We're going to throw this on over here, drag and drop. Really simple. And then we're going to go back into the script, double click, whatever you want to do. And then we need to make a public variable for a game object. And we're going to name it, we'll just name it Bouncy Ball. There we go. For you guys that are coming from C# and haven't used much Unity, basically what I'm doing is I'm making an opening for the Unity engine, this thing, to see the script, and I'll be able to put the model here into the script. And I'll show you that in a second here. So we're going to save, and we're going to come back, and it will pop up here. There we go. And we can drag this and drop it right there. And that will associate this variable, bouncy ball, with this prefab, the bouncy ball. And then we're going to be real nice and quick. We're going to come in here, and on start, we are going to instantiate just one. Yeah, I think we could do just one just to start. Show you guys what it is, what it does. So we're going to do, wrong way, game object, instantiate, and that's an API call. So that's, do that from Unity. And then we're going to give it a bouncy ball. And that's calling this variable here. And we're going to give it a position. But right now we don't have a position. So what we got to do is we got to come back up here, and we need to make a private variable. And we're going to go private vector3. Vector3 is position, and we're going to call it local POS. Well, yeah, we'll do POS. It's basically the position of the object. And then on start, we're going to come down here, and we're going to say the POS is this dot transform dot position, and I did that backwards. There we go. Equals. Excellent. And that is, oh, right, local position, sorry. Right. What? Did I spell it wrong? I did spell it wrong. Look at me, spelling things wrong. Alright, so we're going to spawn it at the local position. We're going to do the transform as a transform dot rotation. And that's basically just telling it, here you go, this is what we want, blah, blah, blah. And because I know where I'm going with this, we're going to do a little housekeeping up front, and we're going to make another private variable here, and this is going to be a list of game objects, and we're going to call it ball list. There we go. And then we're going to come down here. And we're going to we're going to instantiate the list. So we're going to go ball list equals new. And then list game object right there. Just like that. And then we're going to do ball list. There we go. And we're going to do add. We're going to do that, and we're going to do that. It's right. This is a function call, thank you. Or a method call. Yeah. I'm too used to C++. Oh well. Okay, so we're done there. So this is because I know where we're going, but generally you can just instantiate the object and be done with it. So we're going to come in here, and we're going to take our spawner object, and we're going to pick it up, and we're going to play, and we're not going to see anything, because we did it wrong. What did we do wrong? I have no idea. Called the right thing. Just doesn't want to spawn, does it? Oh, we'll keep going here and see if we can't get it to give up its secrets. Alright, so what we're going to do is we're going to make this into a bouncy ball. So that means we need to come into here. We're going to create another folder, and we're going to call this one physics. Because we need to make a physics material. And that's in here. We create, and we come over here to physics material. And we're going to call this bouncy. Then we need to come over to here. No, sorry. We need to come over to here. Yes. And then we need to take the bouncy physics material and drop it right there. And this is the sphere collider, which uses physics material. And the physics material tells you how bouncy stuff is. So we're going to stick that at 0.5 for right now. And we'll come back to that later. So we'll come over here. And then we need to come back into the spawner script. And we're going to really start doing the spawning. So basically what's going to happen is we need a local integer up here. We're going to call it public, just so it's easy. No. There we go. I can spell. I know I can. Int. And we're going to call it number of spheres. Or number of balls, number of spheres, whatever. And then we're going to come down here. And we're going to take this. We're going to copy it. And we're going to do while. We're going to do a while loop. And paste. And then we're going to have a local variable. Int x equals 0. While x is less than the number of spheres. We're going to spawn spheres, and we're going to add to x. There we go. And then we do want to make this genetic, but for right now we're going to do this, just this here, and I'll show you how that works out. But because we're going to be doing this in different places, and because I know what we're going, I'm going to do this. We're going to do void, making another function, we're going to do spawn. And we're going to do, take this, copy, and we're going to paste it right there. And because we don't really care where the local position is, we're just going to get it to once, and then we'll translate it down to here. But we can't have them all spawning right on top of each other. So what we got to do is we have to add numbers, basically. And to do that, you have to add vector 3s. And a vector 3 is, like I said, just a position. So we're going to get a new vector 3. The x position is going to be whatever x is. We're not going to change the y position. And we're not going to change the z position. And this will spread the balls out so that they're not all one right on top of each other. It'll move them along the x-axis right here. And then as the x increases, we'll get to the number of spheres. This will go to one less than the number of spheres, but since x is 0, that'll give us the actual number of spheres, and instead of one more, which is programming. We start at 0, not 1, so that's what we got to do. So we're going to save that, and then we're going to come over here, back to the Unity, and we're going to start moving stuff around now. So, as you can see, the terrain is huge. It doesn't need to be this big. It really, really doesn't. But instead of making my own little what's-its and just kind of having it all squashed together, I figured more room to work is better, so we're going to do that. So the terrain is roughly, here, let's see, there it is. Terrain is roughly 500 by 500. So we're going to stick the spawner here, roughly in the middle. So about 250. And about 250. There we go. The rotation itself doesn't really matter, because it's going to spawn whatever its rotation is. So for right now, we're going to make the height 10. You can make the height whatever you want, but I like 10 for right now because it's nice and easy and it works. So we're going to take the camera here, and we're going to put the camera again in the center. We're going to change the rotations. We're going to zero it out here. Oh crap, I'm working on the directional light and I don't want to do that. Directional light, go back to where you were. There we go. Nope, okay, good. So we want the camera, that's what we want. So camera, come to the center. And then we're going to put you up above the spawner, say 25-ish. And then we're going to change your rotation. 15, nope, 30, yeah, maybe. We'll see how that works. Sort of. No, thank you. Thank you. Good. So we'll keep you there. And then we'll come back over to our spawner. And we will figure out why we're not spawning anything. Other than the fact that we never call the spawning. Right. I completely forgot we switched that. Okay, so in order to call the spawning, we have to call the function. So we're going to do spawn. And we're just going to do that. There we go. Clean that up a little bit. And then this should spawn spheres, until it hits the number of spheres that we set. And to set that number of spheres, we have to come over to here, and we have to type in a number here. And we'll go, I don't know, 3 for right now. So it should have 3 spheres. And if we've done everything right, which we sort of have. They're there. Yep, right there. You can see them. We just have to get the camera correct. So to do that, we're going to focus on the camera, and we're gonna see. Ah, there it is. Okay, so we're gonna pull this back along the z-axis, 40 maybe, and see how that works out. Yeah, there we go. We're gonna have to go a little bit more. Or we could move the spawner, I suppose. We don't necessarily have to have the spawner directly in the middle. Yeah, why don't we do that? We'll move the spawner. So we'll put the camera back at 250. And we'll take the spawner, and we'll move that up to, I don't know, 275. We'll see how that looks. Yeah, that looks pretty good. I like that. That looks good. So, in order to get the models here to go fall down and be bouncy, we need to add a rigid body, which is this thing here. With the rigid body and using gravity, it should, there we go. It should fall down, bounce, you know, that kind of thing. They are a little close though, so we're gonna pop into here and we're gonna increase the range by, I don't know, another half maybe, so 1.5. And this is a float, so we gotta specialize it as a float. And there we go. We'll see how that looks. Yeah, that looks a little better. That looks a little better. But 3 is that's kind of boring. So let's ramp it up. We'll go to 10. See what we get. Camera's a little off, so we're gonna move this to 45. Yeah, that looks more centered. Yeah, I like it. Good, 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 good. So, now that we have the model with our physics material and our rigid body working, we're going to come back into the script and we're going to start the genetic process. So to do that, we need a different spawn. And the way we're going to do that is we're going to take this spawn here, we're going to copy it. Actually, we don't need to copy it, do we? No, we can just do this. And we need to add a game object. We're going to call it object. And then to do that, we need to get the object. And we're going to change the color of the object, just because we want it to be different. And that means that we need it to be a different color because we don't have any other indicator. We could make it a cube or something, I guess, but that would make it look weird. So we're just going to go to object dot get component, because we're trying to get the material component. And we're going to do render. Oop, nope. Because that's where the material is. I'll show you in a second. And that's a function call. And then we're going to get material. And we're going to get color. And the color is going to equal color, which is a Unity thing. And we'll go with cyan. That works. So now we've changed the object's color. Now we need to make the object again, so that it comes back into the play space, basically. We will be getting rid of these objects each generation, so it doesn't fill up. But for right now, we're just going to work on this spawn here. So what we need to do is we need to get our ball list dot add, we're going to instantiate, so game object. That did not do what I wanted it to. Game object. Instantiate. And it's just going to be the object. Just that simple. And then we are going to take the ball list here, and we're going to take the first one, because it will be the first one once we get the destroying script in. We're going to take the transform, and we're going to get the position, so we can see which object is the one that did the best. And we're going to do a new vector 3. We're going to get local position. We're going to get the x of the local position. And we're going to get... Actually, no, we don't need the x. We need the z of the local position. Sorry. We need to get the object dot position, I believe. No, transform, sorry. Transform dot local position dot x. And then we need to get the local position y and dot y and local position dot z. There we go. So that way we'll see which one did the best. And then we need to call our spawn script. There we go. Oops, sorry, that's the method. Here we are. So, in order to make that genetic, we need to actually change what happens here. And to do that, we're going to need a material. So we're going to do for each game object ball in ball list. We need to make a new material. I need to make a private physics material. Oops, sorry. And we're going to do physics material. And we're going to do bouncy material. There we are. And then we're going to do bouncy equals new material. Oh, sorry, physics material. And then we need to do... Oop, crap, no. Do this. We need the bounciness to equal a random range. I didn't need to do that. I need to do that. Between 0.0, because this is, it goes from 1 to 0. It's a percentage thing, to 1.0. And we'll never actually get to 1.0, which is good, because then we would bounce forever, and that would just not be what we're looking for. Then we need to end that. And then the object, the ball, dot get component. We need to get the, not the render, we need to get the sphere collider, because that's where the physics material is. We get the material equals our new bouncy material. There we are. And that means that every new object that spawn will have a different bounciness. this right here, this is called the mutator. And this is what gets us our genetic, basically. So this is going to change every generation. So every time we spawn 10 spheres, we're going to get a different bounciness for each sphere. You can make this as random or as precise as you want it to be. We could just have it change by 0.1 or 0.01 or something like that for every generation. But for this, it's just a quick tutorial of what genetic programming is. So the mutator range is not really a big deal. What it is it needs to be random. Because you don't want to, when you're doing a genetic, you're searching for a spot on a graph that you don't know. So if it's not random, then it's not going to be able to find that spot. Or if it does find a spot, it might be a local low or a local high, and it's not the actual spot you're looking for. So for right now, what we're looking for is the highest bounciness, which we'll get to in a second. And to get the highest bounciness, we want the spheres to figure out which is the highest bounces, which has the highest bounce, and we're going to spawn that sphere. And then that sphere is going to come back every generation until it gets booted out because something else bounced higher. So we will eventually have the highest bouncing sphere. It's going to be a little more dirty than that, but that's basically what we're doing with our genetic program right now, is finding bounciness. But to do that, we need something to tell the program, hey, this is actually the best bounce. So we need to come back into here, and we need to go to our prefabs, which is in our models, click on this, and we need to add another script. So we need to create a C# script, and we're going to call this the ball script. There we go. And we'll come back over here, and we're going to drop that there. Then we need to come into the ball script. Reload, that's fine. Yes, thank you. And we need to get basically a counter. So we're going to do a public float, just so we can see what we're doing. And we're going to name it score. And then we need to basically do this quick and easy. We're going to make a private, and it's going to be a float, and it's going to be the start time right there. And then we need a private rigid body. And we're going to call it this sphere. There we go. The reason I did this is because I've tested this before, and this is what works best. Unfortunately, I don't know why. It won't work without it. So we're going to do this, and it's initial time. Oh, sorry. Start time equals time dot, no. Thank you. I know what I was doing. Time since level load. And this actual thing here doesn't really matter, because we're just getting basically a start time. We need to know when things started. And then the sphere needs to be instantiated, so we're going to do this sphere, this dot get component, get component, and then we need the rigid body. There we go. And we're going to do that and that. And then we're going to come over here, update, and we're going to do if. This sphere dot is sleeping, and score equals 0. So basically, if they get tapped or something, they won't start counting again. We're going to do score equals time Yes. Okay, time since the level loads. We're gonna get this. Copy. Am I doing that? No, I'm not doing that right. There we go. That's better. Minus the start time. There we go. And that's that. That will give us a score on each individual sphere. And that means that when we come back over here and we click on hello, I didn't think I was. What's your problem? Unity engine.time since level load cannot be assigned to is read only. Alright, we got our scoop. I spelled that wrong. Oop. There we go. There we go. Okay. Ah, right there. I pressed the wrong button. That would be why. Thank you, engine. Is that good? Did we get rid of it? Thank you. Good. And so if we come back into here and we look at this, it should have, yep, a score. So if we press start, we're going to save it. Quick save. And give it a shot. And there we go. See, they bounce differently. If we click on one of these, it'll have a score. So what we need to do now is we need to come back here to our spawner script. And we need to get that score. So we're going to come up here and we need a function. So we're going to do void scoring. And we're going to do that. And then for scoring, we need a temp object. So we're going to come up to the top here and make a private temp object. Game object. Temp object. There we go. And we're going to go temp object equals our first ball list entry. That one we need 0. There we go. So now it's initialized, it has a value, and we're going to go through each ball list. Game object, ball, in ball list. We need to see if sphere dot, no, not sphere collider. Oh, right, I named it differently. Ball dot get component, and we need the ball script. Did I spell that right? I did not. There we go. Dot score. As long as it does not equal 0, we can do did I still not spell it right? I put it on the prefab, right? Yeah, I did. Hmm. Let's try that again. Get component. Ball. It knows what score is, so maybe it's just being a pain. We'll find out. So we'll go with if temp object dot get component ball script dot score is less than equal to ball dot get component. Actually, I can just copy this. There we go, copy, and then we're going to throw that in there. Then we need to temp object equals ball. There we go. And that will take the highest scoring ball in each generation and throw it into the temp object. And then we need to destroy the ball. That way it gets it off the field, and we're not worried about it being spawned. Or multiple spawns, infinite balls, that kind of thing. And then we need to clear the ball list, so we need ball list dot clear. And then we need to call the spawn. And we need to call the spawn with the temp object. There we go. So this one, because it's overloaded, so there's no variables it requires in this one, but there are in this one, so it knows to go to this one here. It will the object will be our temp object, which will get changed into cyan, will be added to the list, which will be 0 because we cleared the list here, and the position will be its X position, where it was, and we'll call the spawn, which is here, which will spawn everything else. So we need somewhere to call our scoring script. In order to do that, we need to know when all of the balls are stopped. So what we need to do for that is we need a coroutine, which is a fancy way of saying we need the computer to monitor stuff while we're waiting. So we're going to do an I enumerator, and we're going to call it wait. And it doesn't like that for some reason. Oh, because it doesn't return a value, right. So we're going to do while, and then we need a variable up here, which is a private, and we need a bool, and we're going to call it scene active right there. And while scene is active, we're going to continuously do this. We're going to look through the ball list, so for each game object ball in ball list go. If not ball dot get component ball script. Oh, sorry, no. Nope. We need the rigid body. Sorry. Dot. Oop, nope, that's a function. Now dot is sleeping. We need scene active equals true. And break, because we don't want to do anything if the balls are not sleeping, which is what this exclamation mark is for. So if it's not sleeping, the scene is active, and we're going to break. We're going to break out of this for each and try it again. So else, if the ball is not sleeping, we're going to call the scene not active. And then we're going to yield the time. So this is happening as everything else is happening. So we need to yield back to the program. So return yield, return back to the program. And we're going to wait for a few seconds. Wait 4 seconds. And we'll go, I don't know, 2. Doesn't matter. You can make it whatever you want. So basically what's happening is we're in a while loop. So this loop is going to go continuously until this is false. So for each ball in the ball list here, we're going to check if it's sleeping. If it's not, we're going to be, the scene active is true, which means this is going to continue going, which means this will break, come down to here, and then this will yield back to the main program and wait for 2 seconds, and then come back to this, and then the while loop will run again. And if this is not active in that time, it'll go back to the next ball and keep checking each and every one until the while loop is not active. So then we can do if, just to make sure, the scene not active, we can call the scoring. There we go. Which we'll call this up here. And then that will call the spawn here. This spawn here. Which we'll call this spawn here. Which will get everything working again. So now we need to call the enumerator. And to do that, we're going to come down here into our spawn list, and we're going to say start coroutine, and oops, sorry, wrong way. That one. Wait. And we need to make that, and there we go. So now when spawn is called, it'll spawn a bunch of balls, start this coroutine. So this will wait, and then the balls will do their thing. And once they're all done bouncing, this will activate, which will activate the score, which is this one here, which will destroy all the balls, clear the list, and take the best ball and put it into the spawn, which will spawn again and again and again, and it will just repeat over and over and over again. So it looks like this is going to give me problems. So we're going to have to figure out why that is. In my notes, we have, let it update a bit. Oh, it might not give me problems. Are you done being mad? Here, why don't we do this? So we're going to rename, we're going to copy, and we're going to paste it. No, it doesn't want to do that. Very, very interesting. Well, I didn't do anything different in my test, in my notes. So I'm going to have to assume it's just going to work. We're going to save it. And if it crashes, it crashes. We'll just saved. We'll try again. So we'll see. See what happens here. Ooh. Yeah, it might not like that. Task Manager. Has it broken? It certainly has. Alright, we're going to end that test then. And then I'm going to come here and we're going to get a Unity again. There we go. And we're going to go pop that back up. And here it comes. And this is why you save the scene, everyone. Because stuff like this happens. So we're going to open that again. Spawn an object, our cameras, they're all in the right place, good. So, now we have to find out why this isn't working. If for some reason it can't find the component. And it is on the... It is on this, right? Yeah, the class is the same, so it's doing good there. How about you, notes? They're both in the right namespace. Yep. Well, this is an interesting conundrum, isn't it? Oh, I bet I know what I did wrong. You come with me. Oh, sorry, one too many. And you come down here. You better now? Nope, not better now. Well, that was worth a shot, I guess. Something up here throwing a fit? Nope. Okay. Really wants me to make them uppercase, huh? Suppose I could. I don't think it's going to help with our problem, though. All right. All right, folks. Well, I looked up the problem, tried to figure out what it was, and it seems to be one of those problems that you fix by starting over, which fun. So here we are. I took my. I'm not on the project we were on. I'm taking the actual project that I tested everything on, and that I have everything finished on, and we've got the scoring function right here. So basically, everything's the same, other than we stop the coroutine here, just to make sure that it's done. We get the temp object, we initialize that, the for loop here, as we had the last time, and again, these are all the same. This sphere instead of ball, basically. The score text I will show you in a minute, but basically the function does the same thing. It clears the sphere list, it destroys the spheres, and it calls the spawner, which is this down here, which again does the same thing, does the color, instantiates, transforms the position, and which calls this one here, which makes sure the scene is active. And then this one gets the local position, but I mean, it doesn't matter where they get that, so. Because they're getting that from the spawner and not any of the prefabs. So it's always going to be the same, the spawner doesn't move. And I did add dynamic friction and static friction just to be have more variables, basically. So we're still looking for bounciness, but we're technically looking for movement. So when we run the thing, it'll run, and it'll bounce, and it bounces, and then it's the time from when it starts to when it stops moving entirely that makes the score. So that means we're getting the highest time people move, which means that static and dynamic friction would affect that somewhat. And again, makes the material, adds the material, starts the coroutine. We've got the coroutine here, which isn't different. This is exactly the same. And yeah, that's where that is. So the score, the text for the score is here. This is the canvas thing here. And basically how you get that is you just go to UI and you click text, and it'll make this canvas, this event system, and it'll give you a text thing here. And the text thing, you can put that wherever you want. So I've got it set up here, and you give it a default text, and you can do font and size and all that fun stuff. And then in the script, you get a reference to the score text, which is this here. And you can see that opens this up here, where I just dragged and dropped that over. That's all I did there. And then I set the text to highest score here at the start. And then when scoring is finished, I set the text to the highest score, and I get the actual score from the game object. The buttons here that you saw when I started last time, these buttons here, they're done in this button controller, which is just an empty game object that I renamed and threw this game controller script on. And that's this script here. And it's nothing fancy. I just on the GUI, and then I spawn the button, and then I increase the time scale. That's all it does. It doesn't do anything fancy. That's all Unity stuff. There's no genetic programming in there at all. That's just to make the spawning go faster. So as you can see, this is kind of slow. And if you want to do 300, 400, 500 generations, you don't want to go that slow. You want to go really fast. And you could certainly add another text. Here, I'll do the one right now here. We can add a text. And our text can be just under the top text here. And throw that on there. And it's position Z, right? Not enough. Sorry. That is the wrong number. It needs to be minus. Nope. It must be Y. Yeah, it is Y. So we'll go 15. 15. That sounds good. Generation. And which color did we use here? We used that color. So we're going to use that color again. There we go. And we're going to call this rename generation text. There we go. And then all we have to do for that is come back into our spawner script, make another text, and then we're going to go generation. There we go. Brain fart. And if you're going to do text, folks, make sure you put in the Unity Engine UI using statement. Otherwise, it won't know what text is. See, if you do this, then it throws an error, doesn't know how to use those. So you got to have that in there in order to use text. And then all we have to do, we're going to start this as a 0. Generation equals we're going to need a private int. And we'll call this one number of... Oh, that's not going to work, is it? Number of generations. There we go. And then we're going to go number of generations is going to equal 0. And then whenever we do a scoring, no, whenever we do a spawn, just before we start the coroutine, number of generations gets an addition. Now that plus plus is part of C++ and C#. It just adds 1 to the number. That's all it does. It's the same exact thing of doing plus equals 1. Or equals number of generations plus 1. They're all the same. They also do the same thing. But this one is nice and simple, and it's quick and easy. And that's all that is. So whenever we do that, we're going to update where do we want to put that? We could put it update, I guess. No, we'll put it up here at the top whenever it spawns. So generation dot text equals generation space plus number of generations dot toString. There we go. That's all it's going to take. So it's going to take that number and it's going to add it to that. And then you'll see that here in a second. And boom. Or not. Object reference. Oh, right. Oops, I'm sorry. That's my fault. I need to stick this, and I clicked the wrong thing. Undo. Stick that right there. And now save it. And that should... There we go. And we can switch that up to 10 times. Then you can see the generation we're on. And yeah, there you go. That'll tell you which generation it's on and the highest score. And then I have the ball here. It's sitting in the position of the one that it's a clone of, basically. So if we split that back down to 10, it will switch on occasion, but it'll only switch if one of these gets higher than that. Which doesn't look, it looks like we've reached one of the maximums. So we have seen this number go higher, so we know this is a local maximum and not the absolute maximum. Which is why you have a random mutator and not just pick the biggest number you can. So if we come back in here, you can see this isn't changed. I did get rid of this because I managed to get it working. So I got rid of it from up there and just stuck it down here. But other than that, it's exactly what I went through with you guys in the video and in the previous half of this video. And there's not really anything special or different about it. So for this one, I will be sticking in comments and sticking it up on GitHub, which I will put the link to in the description of the video. And if there's any questions or comments, please make sure to write them in the comments, and I'll try to get to them. But other than that, I hope you all had fun watching, and I hope you all have a nice day. And and I hope this was educational to you all. So, see you guys later.